Hi, it's very good to be here. Thank you for having me and for hosting this event. My name is Allison Clift-Jennings. I'm the CEO of a company called Filament. And just real before I get into the world of what we look at, I'm super curious, and maybe you did this earlier, and if so, I apologize. I just got in today. But who here is not in oil and gas but still in supply chain? Who works within that industry? Wow, okay, way more than I thought. So, okay, that's helpful for me because we spend a lot of our time in supply chain in general, not necessarily in oil and gas supply chain. So in short, Filament really focuses in this kind of weird world of the intersection of the blockchain and the Internet of Things. And this is two very hypey spaces right now, to be quite honest. But behind the hype, there's some really fundamental technology that I think you're all learning about today. If you haven't already learned about it or knew about it, it's fundamental, and it's a pretty big deal, I think. So Filament looks through the world of the blockchain from the point of view of machines or infrastructure. Because we spend a lot of our time in this space, we don't really spend a lot of time on the people side of blockchain. In other words, we don't necessarily deal at the contractual level, I'll say. We deal at the machine level. We deal at the level of atoms and bits, infrastructure, the actual sensors themselves. And right now, 71% of infrastructure globally is offline. So these are trillions of dollars of assets globally across different industrial verticals that are all still disconnected today. And all you can do with them is visually read them or read gauges on them or observe them as humans. And you write down on a clipboard usually, and then you go back and do your thing. This is a lot of the promise of the blockchain, is that we can start to take the paper that comes off of these sensors and we can start to put them into a blockchain. And now we can start to trust. Trust is really at the core of this all, and I think we've heard this quite a bit. But there's a big problem with the trust, and I'm going to say something somewhat controversial. I don't think the blockchain matters much unless you can trust the data going into it. Because all you have at that point is, instead of data in, trusted data out, or perfect data out, what you get is garbage in, trusted garbage out. And that's kind of a problem, right? Because in fact, it can even be worse because people will think it's trustable even though it's incorrect or it's fraudulent going into a blockchain. So Filament really focuses on trying to bring trust to machines, literally allowing machines themselves to be trustable economic actors. It's not uncommon to consider machines do some things really well and they do other things terribly. Computers in general can do things much faster than us. That's why we all use Excel. That's why we all use email. However, if you can't establish machines as trustable agents in a blockchain network, then a lot of the other things will actually be can actually spiral out of control because they'll run at machine speed instead of people speed. So through a long trajectory, I'll touch a little bit on what Filament does, and then we'll get into some interesting use cases. But Filament also, as mentioned by some previous speakers, fell into the blockchain space. We started in the industrial IoT space. We were focused on several different verticals, including oil and gas, but also manufacturing, automotive, what else? Agriculture, and then also energy and construction. So these were different verticals that also had same problems of people trading papers back and forth. Long story short, we ended up realizing that we had this trust issue with machines as well. In fact, we had customers who wanted to pay us for the use of our products, our platform, our sensor network, per use. They wanted OpEx, not CapEx. And so we had this fundamental problem of trying to provide that to them, allowing machines to self-execute this concept of a smart contract, right? Which in our world, the definition is a self-enforcing, self-executing contract written in software. So in short, we really wanted to bring about the ability for machines to transact and enforce on their own so that we could sell our product to our customers. What happened, of course, is some customers said, wow, that's pretty interesting. We'd actually like to license that capability out. We don't really want your sensor. We don't really want your platform. We actually want to sell our products in that fashion. Anything from as a service, a product, or machine as a service, to more complex service plans or service agreements, and all sorts of other things that blossom from this blockchain space. So Filament has developed essentially an integrated hardware and ledger solution that allows for these machines to be economic actors in a blockchain. So we are in the semiconductor industry, so that means we make a chip. I brought a little demo version of ours today. It's very small. The chip itself acts, if you're familiar with the blockchain space, acts as what's considered a hardware wallet. A hardware wallet is what stores the secure keys, the cryptographic keys, both private and public, so that a client can interact with the blockchain. So if you're familiar with Trezor or Ledger, which are human wallets that we use today in the blockchain space, this is one of those for machines. So the idea is with your phone, you can actually pay a car to use it, or you could pay a truck when it pulls up to deliver your goods. You can actually transact at the edge. Without machines to pay or to be paid, you can't really do that. You still have to go talk to another human. So luckily, we have a lot of different investors who are deep in semiconductor space. You don't get into the semiconductor industry unless you have some good partners. And so Intel Capital, Samsung, Flextronics are all investors, among others, of Filament. So we can stand up here as a 20-person team and say, yes, we're making a semiconductor for the blockchain, actually the first blockchain native semiconductor. So where Filament sits here is we kind of sit in this weird blue spot, which means we don't make infrastructure on our own. There's trillions of dollars of those infrastructure deployments already existing. We also, somewhat controversially, don't do anything in the cloud space. We do some optimizations of certain blockchain implementations, specifically in the Hyperledger network, that allow our machines to operate with them natively. But we sit in this middle area to provide this secure identity and what we call a value transaction layer. So kind of like an economic protocol stack. As a quick aside to maybe this might put a different point on it, in the internet world, for many, many years, we've dealt in the concept of data. Data as the core fundamental atomic unit of what we're doing, which is communications and networking and ideally knowledge and wisdom and information. Data is kind of like your atomic unit that you would pass around. And this was the case since the original underpinnings of the ARPANET back in the 60s, as you heard from Professor Matsuo earlier. What we're seeing now is that the fundamental atomic unit of economics is trust. And so we have to bring trust to the edge, to the actual machine itself, if you want the economics to actually pan out. And while we can come at it from a top-down effect to say, like, let's take one small business process and put it on a blockchain, Filament is pretty opinionated in the sense that why don't we start from the bottom up and let machines have this inherent trust platform on which to build, because then we may not even need to do the same business processes. So we might be able to replace them altogether because we're working with different fundamentals. So what Filament looks like is we have a couple of different implementations. We have the chip itself, which is again a standalone semiconductor that acts as a secure blockchain native chip. We have a small USB key, which I showed earlier, which has the chip inside it, but you can plug into existing machinery or infrastructure. This is super important because of all of those trillions of dollars of assets out there. You cannot actually just replace them with a chip inside. And then we have this thing called a trusted app, which, without getting deep into it, some of the newer chips within your phones, within your tablets, within computers have this concept called a secure enclave. And inside that, you can run trusted code. In the Intel world, it's called SGX. In the ARM world, it's called Trust Zone. Both of these allow you to run trusted applications on it. And we have a version of our software, our chip, that runs in that as well. So you could load that onto an existing phone or mobile deployment. So let's get to the use cases. So we did this pilot in the supply chain about a year and a half ago with a major contract manufacturer for electronics and some white label goods as well. This is a typical RFID reader, very boring, but it does read a lot of what's going on within a supply chain, especially at the manufacturing side. The problem is a lot of these companies would come along and have something like, let me just go back, would have something essentially like a manufacturing line. In the electronics world, it's a pick and place machine and it's a reflow oven, and then there's some X-ray devices that will actually optically review. Everyone manually checks this. And we had considered with them what would it look like to just have somebody read off the same data that they're doing and put it in a blockchain. What we wanted to do is actually allow the RFID readers, which could sense what machines, or rather what output is happening at what point on that manufacturing line, and let the machine put it in a blockchain directly. Essentially completely remove the trust requirement of a human in the process. So we took our device and we stuck it into existing RFID reader. It had a USB port so we could plug it in. And here's a manufacturing line, a piece of equipment. We added it to that as well, to a diagnostic port. And what this allows then is to let this machine act as an economic actor on that same blockchain. And then, of course, there would be they could communicate with each other because they have an existing industrial network there. So we don't do that today. We let them do it. But we act as the root of trust for these machines to start to attest what is happening, what they're seeing. And it becomes very hard then to introduce fraud or even negligence within the system, because you'd have to actively inject something that isn't supposed to be there. And then, of course, there's a blockchain that would, a permission blockchain they would operate with. And the servers on those blockchains also happen to run our device, because you want to trust the servers as well with a hardware wallet. If the wallet isn't secure, then the fundamental, remember, that foundation of trust is no longer there. So I'll stop there. I want to open up for more questions, but it's great to be here again, and thank you so much. Questions?